So, Assalamu alaikum. So, we are having just a minute. Yeah. So, we are going to start with our, let's say, question number. Let's start with question number 4 in this case, where it's a 7B, question 4. So, in our first question, we have, let's say, the question is an arc of a circle subtended at an angle of 2 rad at the center. That means arc of a circle, that means a portion of a circle which is subtended from the center, which has a degree of 2 rad. Okay, so 2 rad, that means 2 radians. Now, I would urge you to have your calculator set to radian mode so that like it's easier for you to calculate the maths. Now, it is saying that if the area of the sector is formed is 64 meters square, that means, so if it's 64 centimeters square, that means the area given is 64 centimeters square. Find the radius of the circle. We know the area of sector is equals to half r square theta. Now this theta is in radian. Okay, remember these are sums we are doing in like radians. Usually we tend to do this sort of sum in radian. However, there are certain maths where the angles are given in degrees. In that situation, you have to convert those into radians. How do we do that? Theta divided by 360. Okay, simply do that, you will get the radians. Okay, now now for this part, area of sector half r square theta, using this formula, we are given 64 as the area, which is equals to half times r square times or theta, which is 2 in this case. Now subjecting r square, we should get this 2 to cancel out, r square equals to 64. We are left with r equals to root over 64, which is 8. That means our radius is 8 centimeter. Now moving on to our next one, we have question number 5. Question number 5 says, sorry for the mess. Question number 5 says we have 5 of 7b. It says find the area of a minor segment formed by a circle. Segments. What are segments? In a circle, starting from the center, in the sector, let's say this is the sector, isn't it? In the sector, if from one of the point of the arc, this is the arc, let's say, this is the required arc, okay? One of the point from the arc to the other point of the arc, if we draw a straight line, okay, then we get a segment here, okay? These are known as segments. Now they're saying in that segment, find the area of the minor segment formed by a circle of radius 6. That means its radius is given 6 centimeter and a chord whose distance, this is known as the chord, okay? This was which we drew just, this is known as the chord. So this is known as chord. This chord has a length of given 3 centimeters. Now they're asking us to find the area of the minor segment. Okay, so basically, just give me a second. Okay, so basically the segment represents is this one, okay? This is known as our segment and this is another segment. So when they ask us to find the segments, what are these segments? This is known as the minor segment and this is the major segment, okay? Major segment. Leaving this one apart, this one is the triangle. This one is the part which we don't need or which is out of the segments part, okay? This is not the segment. The segments are, these shaded regions are known as segment, where the largest part is the major segment, the smaller part is the minor segment, okay? Now they're asking us to find the, or calculate the area of the minor segment. Okay, before doing that, we have to do some calculations here. Now, in order to find this segment, how can we do this? We have this sector here, okay? If we have this sector which we can find, whose area we can find, another thing we can find is the area of this triangle which is inside this sector. So that means this sector. If we subtract this like area of this triangle from the entire sector, we would get this segment present here, okay? So let's do it step by step. Step one is finding sector. But before that, what do we need in order to find a sector? The area of sector is half r squared theta. We need a theta here. We don't have a theta here. What should we do? Okay, let's see. This is our chord. This is our, like, this is the sort of the part of subtended like circle, yeah? This is the 6 centimeter radius. This is also 6 centimeter radius. So these and these are equal in length. That means what? We can consider, let's say, this white part. We can consider this white part as a what? A triangle, but more specifically, this is an isosceles triangle. Now, what does isosceles triangle have in common? They have two sides which is equal in length. That means two of the angles are same inside, like same in their like angle. That means these two angles are equal. Now, we don't have any of the angles present here. What can we do? This the chord length is given. Now, from this chord length, we can draw a straight line which represents the 90-degree height. Now, how do I know that? Let's draw a isosceles triangle. If I draw an isosceles triangle, then the shortest distance from this point to the base is the height, which is 90-degree apart, okay? This is a 90-degree, like this, the angle between these two sides is 90-degree. Now, this is given 6, this is given 6, and this total entire length is what, 3. That means one of this base is what, 1.5 meter? This is 1.5 meter, okay? See, we have two of the values here present, 6 and 1.5. So we can use actually that SOHCAHTOA formula. We do need this entire angle, isn't it, in order to find the sector. So what we can do is try to find this angle first, then we will multiply it by 2. Now let this be theta, or let this be alpha. So alpha, how can we find alpha? So we have, according to this alpha, which one is adjacent, which one is hypotenuse, which one is our opposite. So let's draw it first. This is our triangle. Now that's our alpha, okay? This is our alpha. Now, according to alpha, the opposite side is this one, which is 1.5. The adjacent side is this one, which is unknown. This is the adjacent side, which is unknown, and the hypotenuse is 6. So which formula can we use? We can use simply sine. So sine alpha is equals to 1.5 over 6. That means alpha is sine inverse of 1.5 over 6. Remember to calculate things in radian, okay? Now, once we have found alpha, theta means what? 2 times alpha. Why? Because one of the side is, this angle is known as our alpha. That means what? Entire angle is 2 times alpha. Like that. That means theta. Why? Because each angles are equal in length. Now, the case, then